Hello and welcome to this session. This is part 4 of the series on Spring Security, and in this video I'm going to show you how we can use Spring Security to perform a database-based authentication on an already existing user database. So this video is for those users who already have an existing user database, maybe a table name like user inventory or user list or whatever. So that table is not mandated by Spring framework. So in such a case, how can we integrate an already existing user database with the help of Spring Security and secure that application? Now let's jump into the demo to see how we can do a database-based authentication. So let us start with the demo, and this is the springboot project, and this project is in my GitHub repo, and the link to this project is in the description of this video. And please note that the branch is springboot security using JDBC MySQL-2. So just like my previous video where also I showed how we can actually use Spring Security to enable database-based authentication, for this video as well, the prerequisites are exactly same, that I am setting up a Docker-based MySQL database. Of course, you can have a locally installed MySQL database. So that will also behave exactly in the same way. The only difference between the last approach and this approach is that in the previous approach, we were using the Spring mandated tables, like the Spring Security mandates the table names as user and authorities. Here, it is completely different, which means we can actually integrate Spring Security to read user details from any user database in our infrastructure. So this is exactly for you guys, for those of you who already have a user database and want to integrate it with Spring Security. So let us go ahead and see how the project structure looks like. We'll start with the POM, and the POM is something which we expect, like the Spring Boot Starter Web, the Lombok, the Starter Security, Spring Starter Data JTBC, and the MySQL driver. So that is fairly on expected lines. And then we will go to the web security config. So in web security config, again, I have defined the data source here. Of course, this could have been defined also in the application YAML, and the password could have been in production. Actually, we will encrypt the password. So I also have a video of encrypting password, but for simplicity, I have not done it here. So this is the web security config. If you have seen my last video part 3 of the Spring Security series, then you will see that here in that video, also to connect to a MySQL database, I had actually defined another bin of JDBC user details bin, JDBC user detail manager bin, which is required in that approach. But in this approach, we are not going to define that bin. Rather, we are going to define a specific service, and we are going to implement user detail service, which is part of the Spring framework again. And this user detail service is an interface with a single method with the name load user by username. So what we need to do is we need to just override the method, and in this method we need to actually write the code to fetch the data from our custom database. It can be, so I have just denoted it here as users2. It can be anything like user-inventory, user-list, whatever your custom user inventory is. From there, we need to fetch the user detail and populate this user object, which is another internal object within Spring Security. So this user object contains some attributes, the first two being the user ID and the password stored in the database. So all what we need to do in this method is query whatever custom database we have, whatever custom table we have, and then populate this user object. So that's all what we need. Now, again, I will show you this README. This README is also very similar to the previous one. Just like the previous one, I have used Docker container to set up MySQL, and then once the MySQL database is running, then I enter into the MySQL container, then created the database, and then use the database to create 2 tables. And by the way, these tables could have been named completely different, and in fact here I am not even using the authorities table. We could have dropped that as well. So I'm just using the user table and users2 table and populating it with the value, and again populating it with the password. The password is a bcrypt encrypted password. I talked about the same thing in my last video where I explained why the password is bcrypt encrypted, because once the user is going to send his plain text user ID and password, then what Spring Security is going to do is it's going to hash the plain text password and then fetch the hashed password in the database and match both the hashes. This is exactly how password verification should be done. We should never store plain text passwords, neither encrypted passwords in database. We should only store hashed passwords in database, and we should hash the input password and match the hashes. And bcrypt is just one of the most popular hashing algorithms. There are many others as well. I will create another video which will discuss about the details of all the different hashing algorithms, password hashing algorithms, which Spring Boot security supports out of the box. But coming back here, so you can again then follow the steps here to actually create the package and to run the program. So I have already done that in order to save some time during this demo and in order to give you the best value for your time. So already the server is running and I have this users2 table. So I can query the users2 table. It's very similar to the default user table because I have created like this for the demo, but you can actually have a completely different table. And as long as you are querying that table and you are able to populate the data within this method, then it is fine. So now what I'm going to do is I'm going to send an invalid request and then I'm going to send a valid request. So this is going to be an invalid request because it has not sent any authorization header. And then I'm going to send a valid request which will send an authorization header. Remember, this authorization header has got nothing to do with Spring Boot or Spring Security. It's a HTTP standard and the username and the password should be colon separated and then base64 encoded. And I have always given one very small Java application to actually create that base64 encoded user colon password string. So that is a HTTP standard. So what Spring Security does is once it receives this particular header, then it decodes the header and gets the plain text user ID and password and then converts the plain text password to the bcrypt hashed password and then match and then basically query the database to retrieve the user detail. And once the user details have been retrieved, then it match the encrypted password, the hashed input password with the hashed password stored in the database, and if it matches, then it lets call the controller. So that's how the controller is finally invoked when I'm giving a correct header. So that's about the demo. Please also run it yourself, but I also want to show you a couple of things regarding the internal working of Spring Security. So now with the previous video and this video, we have learned two different techniques of implementing database-based authentication using Spring Security. In the last technique, we were using a specific bean and we were actually creating that specific bean, which is an internal class of Spring Security, but that had a restriction that the users and the authorities table should be as what Spring Security mandates. But here, this approach is more flexible and we can actually use any table to fetch the data. Let's see how Spring Security actually works internally for this database-based authentication. And I have also written the steps here in readme.md so that you can also follow it here. So first, control comes to this DAO authentication provider, which is this class. And from here, from this particular line, it tries to load the user by username. And then it comes to this interface, user detail service. And if you see here, there are various implementation of this interface. And the first one is the approach which we used in this particular demo, wherein you can actually get details from any user. And then there are also other implementations like in-memory details manager, caching user detail service, and this JDBC DAO IMPL. That's the approach that we used in the previous one. So this JDBC user details manager is also overridden by a bin JDBC user details manager. So in the previous demo in Spring Security Series 3, I had actually created a bin of JDBC user details manager. So again, this JDBC user details manager actually uses the internal table of Spring Security, which is the users table, to find out all details. While if you are custom implementing, if you are implementing it by hand, if you are manually implementing this user detail service like we have done here in this video, my user detail service, then you can actually fetch the data from any user table. The only restriction is that it should return this user details bin, and our user bin within Spring Security is an implementation of user detail bin. So if you are able to return a user object, the user object is also a Spring Security user, then so we have returned an user object which is a Spring Security user, then this particular implementation is also fine. So that is how this particular service is working. I hope you have understood how Spring Security routes the call to this my user detail service and then fetches the details. And if this video has given you value, then I would encourage you to subscribe to my channel, to share it with other viewers who you think would benefit from this, and also please provide your feedback as comments, and because that's going to motivate me also to produce other interesting videos. Thank you for your time and have a nice day.